Hi everyone, welcome back. Today we are going to go over math to mass problems. So let's just jump right into it. I want you to write or note that each of these problems is exactly 4 steps. There is no shortcut like there was before. Also, I want you to make sure you have written down this conversion that 1 mole of anything, or any substance, any compound, is equivalent to its molar mass in grams. So if you don't remember what I mean by molar mass, let's go ahead and look at the periodic table. Recall that every single element on this table has a mass. For instance, if we look at sodium, sodium's mass per mole is 22.99 grams. So I mean that 1 mole of sodium is approximately 23 grams in mass. So if I wanted a compound's, say, atomic mass or molar mass, say I wanted to know the mass of NaCl, I would just add the sum of Na, which is a 22.99, plus the mass of chlorine, which is 35.45. I would go ahead and round 35.45 to 35.5. and then add it to the 23. So 23 grams from the sodium plus the 35.5 grams from the chlorine would give me a total mass. Let's see what it is. 23 plus 35.5. 58.5 grams. And that would be the molar mass of NaCl. If I were to have 2 moles of NaCl, I would just simply double this number to get a total mass of 117 grams. So instead of getting lost on that, let's go ahead and look at a couple problems. You notice that 1 and 2 I will do only in class, so we're going to start with number 3. Alright, just like before, let's underline what they're asking, and we're going to see what they gave us in the previous problem. So number 3 actually involves the reaction that was done in number 2, and it's asking for us to find the number of grams of ammonia that are made in the reaction above. So ammonia, it's a compound is NH3, and in this reaction in number 2, it looks like we have N2 plus 3H2 coming together to make 2 moles of ammonia. So it says we had 50 grams of nitrogen originally. So we are going to focus on N2 and 2 NH3. We don't need to focus on 3 moles of H2 right now. So we're going to compare the molar ratio. So for every 1 mole of N2, we have 2 moles of NH3. We just got these two numbers from the coefficient in that reaction. Now, just like all the other types of conversions we've done before right now, before today, we always start with the number that was given to us in our conversion. So we're going to write 50 grams of N2 over 1. That's step number 1. We want to convert grams of nitrogen into moles of nitrogen. And in order to cancel out grams of nitrogen, we're going to go ahead and write it as the denominator under here to get it canceled out. So we are looking for the molar ratio. The second step is where we find our molar ratio. So it's always going to be 1 mole compared to its molar mass. So if we look on our periodic table, nitrogen has a mass of approximately 14 grams. So if we have 2 nitrogens, we just simply take 14 and multiply it by 2, which gives us a total of 28 grams. So the molar mass of nitrogen gas is 28 grams per mole. we can then go ahead and cancel out grams of N2. This third step is where we compare the molar ratio that we have above this example. So we're going to write moles of N2 underneath, and we want to convert that to moles of ammonia, which is NH3. So according to our ratio, for every 1 mole of nitrogen gas, we get 2 moles of ammonia. We can now cancel out moles of N2. Alright, we just got one more step, and we're just going to convert this into grams. So we're going to compare it to its molar mass. So for every mole of NH3, we have to find the molar mass of N plus 3 H's. I'll let you look that up, but it is simply going to be 17 grams of NH3. We now can cancel out moles of NH3. So if you see now, the only unit I did not cancel out was grams of NH3. So that's going to go ahead and be the unit for our answer. And just like before, we're going to multiply across all the numbers that we did not cancel out to get our final numerator. Do the same thing to get our final denominator. So what we have is 50 times 1 times 2 times 17, and that's going to be 1700 over 28. We go ahead and put that into our calculator, and we get roughly 60.7 grams of ammonia. Let's go ahead and look at number 4. The question asks how many grams of silver chloride, so that is what we're looking for. And silver chloride, I believe I said sodium, but silver chloride is simply AgCl. And we start with 5 grams of silver nitrate, and that's this right here. So those that we circled, we boxed, are the ones we're going to focus on. So we're going to leave the other 2 compounds alone. Let's go ahead and write the molar ratio up here. So for every 2 moles of silver nitrate, we have 2 moles of silver chloride. 2 to 2. We're going to use that in our formula or our calculation in just a few moments. So remember, we always start our conversion with the number that they gave us. So we're going to start with 5 grams. So 5 grams of silver nitrate over 1. We're then going to do the mole to molar mass ratio. So 1 mole of silver nitrate is approximately 170 grams in mass. Now, if you don't believe me that this is the right mass, go ahead, pause the video, and then calculate it yourself, looking at the masses on the periodic table. So in this third step, we are going to go ahead, I'll switch colors, this one's kind of bright. We are going to compare moles. So moles of silver nitrate are going to be converted to moles of silver chloride. And we use the numbers that are in our ratio. So it's a 2 to 2 ratio. Now we can cancel these out. And the last step is where we do a molar mass comparison. So for every mole of silver chloride, it comprises approximately 143.5 grams of AgCl. Okay. So we can go ahead and cancel out these last 2 units. So all we do is then multiply across. So 5 times 1 times 2 times 143.5 gives us approximately 1,435 in our numerator. 1 times 170 times 2 gets us approximately 340. We simplify that and we get 4.2 2. We are going to round that up and make it simply 4.2 grams of silver chloride. Okay, very last one, I'll let you go. Number 5 is asking how much barium chloride is necessary to react with the silver nitrate. So we're going to again use the reaction that was in number 4. So barium chloride is BaCl2. So I'm going to write that right here. And the ratio is for every 1 mole of barium chloride, it mixes with approximately 2 moles of silver nitrate. Our ratio is 1 to 2 right here. 1 to 2. Alright, so we're going to start with the same starting point we did in number 4 because we were given 5 grams of silver nitrate. So, starting off right here, I'm going to zoom in. We have 5 grams of silver nitrate over 1. We then compare that to the molar mass. So it's 170 grams of silver nitrate for every 1 mole of silver nitrate. We then can cancel out this. Step 3 is where you compare the molar ratio. So for every 2 moles of silver nitrate, you have exactly 1 mole of barium chloride. You cancel out moles of silver nitrate. And finally, step number 4, you just do the molar mass of barium chloride. And that mass per mole is approximately 208 grams. And we can go ahead and cancel out moles of barium chloride. So last but not least, let's pick a different color. We're going to multiply across all our numbers. So 5 times 1 times 1 times 208 will give us approximately 1,040. 1 times 170 times 2 times 1 will give us once again 340. And once we simplify this, we get an answer of roughly 3.058. We are going to round that, and our final answer is going to be 3.1 grams of barium chloride. All right, there you have it. So once again, if you need any more help, feel free to watch this video more than once if you miss a step. And if you're still confused, just come ask me and I will gladly give you my assistance. All right, thank you for watching.